Good afternoon. My name is Jonathan Amaso, my partner Johan Castro, and we are going to expose about for electrical power insulators, test methods. Universidad Distrital Francisco José de Caldas, Facultad de Ingeniería, Ingeniería Eléctrica, Aislamiento Eléctrico. Scope. This standard comprises a manual of test methods to be followed in making tests to determine the characteristics of electrical power insulators, as defined herein. In this case, only attend suspension and pin insulator.
Definitions. Suspension insulator is an insulator with attached metal parts having means for non-rigidly supporting electric conductors. Pin insulator is an insulator having means for rigid mounting on a separable pin.
Ultimate mechanical strength. Load at which any part of the insulator fails to perform its function of providing of mechanical support without regard the electrical failure. Combined mechanical and electrical strength. Mechanical load at which the insulator fails to perform its function either electrically or mechanically when voltage and mechanical stress are applied simultaneously.
Time load withstand strength. The time load withstand strength of an insulator is the mechanical load that, under specified conditions, can be continuously applied without mechanical or electrical failure. Mechanical impact strength. The mechanical impact strength of an insulator is the impact which, under specified conditions, the insulator can withstand without damage. Test specimen mounting for electrical tests. Suspension insulator. Mounting arrangement. Unless otherwise specified, the test specimen unit or string shall be suspended vertically at the end of the ground conductor so that the vertical distance from the uppermost point of the insulator hardware to the supporting structure shall be not less than 914 millimeters. Energized electrode. The energized or button electrode or conductor shall be straight, smooth root, or tube having an outside diameter not less than 19 millimeters and no more than 38 millimeters. It shall be coupled to the lower integral fitting of the test specimen so that the distance from the lowest edge to the insulator shell to the upper surface of the electrode shall be between 0.5 and 0.7 of the diameter of the lowest insulator. The conductor shall be horizontal and at right angles to the axis of the test specimen. The conductor shall be of such length that flashover will not be initiated at the electrode ends. Proximity of other objects. No objects others than parts of the test assembly shall be nearer the test specimen or energized electrodes than 1.5 times the test specimen dry arcing distance, with a minimum allowable distance of the 914 millimeters.
Mounting for electrical test line insulators. Pin. Mounting arrangement. Crossarm. The supporting crossarm shall be horizontal, straight, smooth, and grounded. Metallic tube or structural member have a horizontal width no less than 76 millimeters, no more than 152 millimeters. It shall be of such length that flashover will not be initiated at its ends. Mounting pin, if required. When a separable pin is required, the test specimen shall be mounted vertically on a 25 mm diameter metal pin of such length that the shortest dry arcing distance from the upper electrode and connected metallic parts to the supporting crossarm shall be 25% greater than the similar distance to the pin. AW rod. The energizer shall be a horizontal round rod or tube placed at right angles to the supporting crossarm and of a diameter no less than 13 millimeters. The conductor shall be placed in the top conductor groove of the specimen. If a tie Wire is to be used, the conductor shall be secured by means of at least two turns of wire not smaller than number AWG. Proximity of other objects. No objects other than parts of the test assembly shall be nearer the test specimen or energized electrodes than 1.5 times the test specimen dry arcing distance, with a minimum allowable distance of 914 millimeters.
Electrical tests. For all electrical tests, the mounting arrangements are according to previous section unless otherwise specified.
Electrical test. Low frequency dry flashover voltage test. Voltage application may be quickly raised to approximately 75% of the expected average dry flashover. The continued rate of voltage increase shall be such that the time to flashover will be between 5 and 30 seconds after of that 75%. Dry flashover voltage value is the arithmetical mean of more than 5 consecutive values, and the time have to be between 15 seconds and 5 minutes. Corrections. Dry flashover voltage value shall be corrected in accordance with American National Standard Techniques for high voltage testing. Humidity. The dry flashover voltage value shall be corrected to standard humidity conditions in accordance with the curve. The humidity is given by the use of the following equation, where pH is the vapor pressure, Ps is the pressure of the Saturn aqueous, T is the temperature of air, T prime is the wet bulb temperature of air, and B is the barometric pressure. Correction by air density is given by the use of the following equation, where P is the barometric pressure and T is the temperature.
Low frequency wet flashover voltage test.
Precipitation. The precipitation shall be applied in accordance with the following table, where is necessary have the average precipitation rate of vertical component limited for any individual measure, water temperature collection, resistive of water collected, noisy type, and duration of wetting held for trial. Below you can see the type and size of the nozzle used for the constant wetting. The voltage application and the dry flashover voltage value are the same procedures than the low frequency dry flashover voltage test, and the correction shall be made in the dry except the humidity correction.
Low frequency dry withstand voltage test. Voltage application. The voltage application is the same procedures than the previous test. Test voltage and time. The test voltage with its rate dry withstand voltage with appropriate atmospheric correction applied shall be held on the test specimen for 1 minute. Corrections. Corrections shall be made in accordance with relative air density and humidity by the use of the following equation, where V is the test voltage in kilovolts applied to the test specimen. Vs is the rated withstand voltage in kilovolts. Delta is the relative air density, and H is the humidity correction factor applicable for the particular test specimen. Low frequency wet withstand voltage test. The precipitation and preparation of the test specimen are the same procedures than low frequency wet flashover voltage test. The voltage application and the test voltage and time are the same procedures that the previous test. And the correction in this test are only for relative air density, where V is the test voltage in kilovolts applied to the test specimen, Vs is the rated withstand voltage in kilovolts, and delta is the relative air density.
Low frequency due withstand voltage test. Preparation of test specimen. The test specimen shall be placed in a chamber having a temperature of from minus 10 degrees Celsius to minus 15 degrees Celsius until the specimen is thoroughly cooled. Mounting arrangement. In this test, the chamber having a temperature of approximately 25 degrees Celsius. The relative humidity in this test chamber shall be approximately 100%. Voltage application. The voltage shall be raised rapidly to due with some test voltage, while the test specimen is completely covered with the dew. The time to raise the voltage shall be no more than 20 seconds. Test voltage and time. The test voltage, which is the rate due with some voltage with appropriate atmospheric correction applied, shall be held on the test specimen for 10 seconds. The corrections for this test are humidity and air density. Impulse flashover voltage test. In general, impulse flashover voltage tests are made under dry conditions only. Mounting arrangement is the same than the previous explained. Impulse voltage wave, all tests shall be made with a lighting impulse wave. Corrections. For critical impulse flashover voltage, the corrections are humidity and air density. Bold time course. For air density shall be applied. For the humidity, if critical flashover greater than 10 microseconds is applied. If critical flashover is less than 10 microseconds, the correction shall be reduced in the direct radio that the time to flashover bear to the time and the critical flashover.
Impulse withstand voltage tests. The impulse withstand voltage tests are made to determine that the test specimen is capable of withstanding a specified impulse voltage. Correction shall be made in accordance with correction for low-frequency dry withstand voltage tests, except that the curves in the next slide shall be used to find edge. Voltage application. Impulse withstand voltage tests shall be made with an impulses of that polarity which produces the lower flashover voltage on the test specimen. 3 consecutive specimens shall be applied to the test specimen. The crest voltage of each shall be no less than the specified impulses withstand voltage with appropriate atmospheric corrections.
Visual corona test. To assist in locating a source of radio influence voltage, a corona test may be performed. The test shall be made in a thoroughly darkened room. Procedure. A voltage well above the corona point shall be applied and slowly lowered until all these chairs disappear from the test specimen. The point on disappearance shall be the corona voltage. The observer's eyes shall be thoroughly accustomed darkened room before making visual observations.
Ultimate mechanical strength test. The load shall be started at the zero and smoothly brought up in a practical stepless variation to the failure point. The load may be increased rapidly to approximately 75% of the rated strength of the insulator. The rate of the increase of the load from 75% of the rating to failure is given by the following table. Mechanical tests for suspension insulators. Tensile strength. A mechanical tensile load shall be applied between terminal fittings in line with the axis of the test specimen. The mechanical impact strength. The test specimen shall be mounted in a specified test machine in the specified manner under a tensile load of approximately 8,896 newtons. The bearing point of the pendulum shall be so adjusted that, when released, the copper nose will strike the outer ring of the shell squarely in a direction parallel to the axis of the unit and towards the cap. Test for line insulators, pin and post. Cantilever strength. A mechanical load shall be applied in line with the side group of the test specimen and normal to the axis of the pinhole. The load at the tie wire group may be applied by means of a loop of flexible strand cable or the equivalent. The mounting pin connecting hardware and linkage between the test specimen and the testing machine shall be such that no appreciable deflection takes place at the value up to the failure point of the specimen. Mechanical impact strength. The test specimen shall be receive an impact of the specified severity by releasing the pendulum when its shaft is opposite to the corresponding mark on the indicating scale. The pendulum shall be released with no imparted acceleration. After receive the specified impact, the test specimen shall be tested for soundness by momentary flashover. Combined mechanical and electrical strength test. Load shall be applied as described in general from the ultimate mechanical strength test and tensile strength. Simultaneously, a low-frequency voltage of no less than 75% of the rated dry flashover voltage shall be applied to the test specimen.
Time load with sun strength test, mounting arrangement. The test specimen mounting shall be in accordance with the ultimate mechanical strength test. Loading. The specified load shall be applied smoothly, without undue vibration or shock, and maintained for the specific period. After the load has been removed, and test specimen shall be checked for electrical soundness by being subject to momentary flashover. Test specimen having more than one shell shall have each shell checked individually for electrical soundness. Porosity test. Preparation of test specimen. Freshly broken fragments of the insulator having clean surface spots shall be used for this test. At least 75% of the surface area shall be free from glaze or other treatment. Fragments approximately 6 mm and the smallest dimension up to 19 mm in the largest dimension are recommended. Testing solution. For this test, a solution consisting of 1 gram of basic fusion dye dissolved in 1 liter of 50% alcohol shall be used. If a denatured alcohol is used, one should be selected which does not read with the dye to cause fading of the color. Procedure. The test specimen shall be completely immersed in the testing solution within a pressure chamber. A minimum pressure of 4,000 pounds for per 27,600 kilonewtons square meter shall be applied for no less than 5 hours, or an optional test at minimum 10,000 pours for 68,900 kilonewtons meter for no less than 2 hours may be used. At the conclusion of the pressure application, the test specimen shall be thoroughly dried and broken for examination. Interpretation of results. Penetrations into small fissures formed in preparing the test specimen shall be disregarded. Porosity is indicated by the penetration of the dye into the test specimen to an extent visible to the undie.
Thermal test. The thermal test shall consist of alternate immersion of the test specimen in hot and cold water. The test specimen shall be arranged so that they are not in contact with each other and so that air shall not be entrapped during immersion. Free circulation of water shall be provided. Test specimen shall be at least 51 mm from the walls of the tank. Equipment. Each bath shall have a weight of water at least 10 times the weight of the test specimen immersed. Either natural or forced circulation may be used to maintain the temperature of all parts of the bath within plus or minus 2 grades Celsius of the specimen value. The recorded temperature shall be measured at least 102 millimeters from the heating or the cooling elements. Method of making tests. The test specimen shall be first be immersed in hot water bath for 10 minutes. It shall then be withdrawn and immersed in cold water bath for another 10 minutes. No more than 5 seconds shall elapse in transferring the test specimen from one bath to another. After the specified number of hot and cold cycles, the test specimen shall be tested for electrical soundness by momentary flashover. Pinhole gauging test. When the tried pinholes of pin insulators are gauged, the specimen pinhole gauge shall be used. Test procedures. The gauge shall be screwed into the test specimen until the gauge is tight. The distance from the bottom of the pinhole to the point where the gauge stops, as indicated by the plunger and scale on the gauge, shall be read. The gauge shall be removed from the test specimen and the number of revolutions of the gauge required to release it from the pinhole shall be counted. This is a ANSI C29.1 explanation. Thanks for your attention.